Always keep the force.
Oh.
Not so much.
Dame y gospodo. Ahora se una inglés con mi rollo de resume. Alright, so it's a very special pleasure today to announce this awesome group from most of Europe. So a lot of these guys are guys that were always role models, people I looked up to when I started working in the web industry. So they're coming from extensive backgrounds with working with frameworks and super awesome JavaScript stuff. And it's really awesome that they're here to spend a little bit of time to talk about things that are very production related, very sensitive, and very useful. Things that we don't think about sometimes when we launch a business. But I'm pretty sure every business that went live in production has faced issues with errors and exceptions that happen to clients that you cannot reproduce, right? So I'm not going to give the whole intro and steal any spotlight from Mats, but I'm really looking forward to hearing him talk. Before I let him take the stage, just kind of a brief overview of today's meetup session. This is an awesome venue, so we'd be really grateful to Paradox, who let us use the venue for today's meetup. The first round of drinks, beer or wine, is on us. So, please enjoy if you haven't. Once you're done, we're going to go upstairs. There's a beautiful terrace, and we can talk, mingle, or whatever. At 9 o'clock, there's going to be a concert. I hear this is a really good jazz band here. That they're gonna play at 9 o'clock. So you're invited to stay. Listen if you have the time. I think it's going to be a really nice event. Also, Modus Create is our sponsor, as always. So Modus Create, again, sponsored the drinks. So I got to thank Modus Create for that too. I have to say that if anyone is interested in careers at Modus, and that's related to front end or back end position, DevOps, UX, UI, let me know. My email, my Twitter handle, or through the meetup page. You can look me up there, or just look me up after the meetup, so we can talk. All right, so Mats, welcome.
Thank you very much, Gregor. Thanks for having me. Thank you everybody for coming. I hope I won't bore you too much, but we're going to talk about something that's maybe not the most fun thing in life, error handling. So I'm not sure what you're doing here really when it's a nice weather outside, but I'll hope to make some kind of presentation worth your while. So, who am I? I'm from Stockholm, Sweden. I founded the company Bryntse. These guys are my awesome colleagues. We make JavaScript UI components for project management, scheduling, like calendars, Gantt charts, but we also make developer tools for unit testing, UI testing, JavaScript, as well as JavaScript monitoring tools, which is the tool I'll talk about today, and give you some details of how you can work with errors. So our website is www.bryntse.com. If you want to know more, check out our stuff. Please do so. And who hasn't seen this meme, by the way? Has everybody seen that meme? I don't always test. So usually that resonates with startups and companies, that testing is an afterthought. That's what you do later, after you work on cool features, right? But today we'll talk about error handling. So let's dig in. Some basics. So JavaScript errors, when I say that, I mean unhandled exceptions in your code base or in the frameworks you use, in jQuery, React, Angular, Vue.js, EXT.js, it really doesn't matter. If there's an error, it will probably be a poor user impression. The user will be disappointed, and it doesn't really matter whose fault it is. They're on your website, on your web application. And today we're writing JavaScript code bases in the size of megabytes. It's not like in the past where we had the server dump a lot of HTML into the page. Now it's the opposite. So we have a very thin server which does data validation and passing it back and forth, and all the magic, all the nice stuff happens on the client, right? So we can't really ignore it anymore. Good news, it's easy. So as a web developer, I'm sure you've all seen this. Raise your hand if you've seen this in code. If you haven't, you're the best programmer I've ever met. All right. So this typically happens to me like 500 times per day. That's me. So this is what we see. So we kind of understand something went wrong. We know how to fix it. A developer, if you go to a website, a shopping site or something like that, and you click, I want to buy this bag, you click add to cart, you don't see anything, right? The customer here doesn't have a developer console. They have no clue what's going on. So, of course, they turn angry. They start questioning, did I hit the add to cart button? And they hit it harder. And maybe one more time. And then they start hitting, and then they take the laptop and throw it out the window, right? So that becomes a very angry, bad user impression. And maybe they go to your competitor's site. Something like that. So basically, for the end user, there's only two scenarios. So either you handle the error, and you notify the user, okay, this is not good, something went wrong, we're sorry, we'll fix it. Or they don't know at all what happened, and they will try again and go away eventually. If you're really lucky, and this is really, really lucky, they will contact you, maybe send an email, maybe a threatening letter, but then at least that gives you information that something is wrong in production, right? So that those users you should really be thankful for. So if they tell you something is wrong, it means they took time out of their daily life to handle your error reporting for you, which is kind of nice. So yeah, I think we've all seen errors, so I'm not going to have to demonstrate that. So what is a JavaScript error? There is something called the error event constructor, which is fired on the window object, and you get some useful information. Anytime there's an error, you get message, file name, line, column, and stack trace. And stack trace is for normal browsers only, not modern, but normal. So that leaves out IE8, 7, stuff we don't really want to talk about here on a nice Thursday. And to be notified with this, I'll try to zoom in. So you basically just hook up or on error handler to be notified globally when there's an error in your page. And this is called anytime there's an uncaught exception. So it's very easy to be notified. And you can also do it in a more modern way with the add event listener on the window, and that gives you all the nice stuff that you want to know. The stack, of course, which is the most important part. So it's very easy to do this yourself. You can also throw your own errors. If you detect some condition in your code base that should not happen, it's worse to continue than it is to just bail out and abort. So you can throw my own error as a string, which is bad because then you don't get a call stack. Much better to throw a real error, like use an error constructor. But you can use try catch too, just like you can in any other language. And then how many of you have seen script error, the magic script error? Some very cryptic error message. Yeah, so this happens when you include script from some other site. So if you use a jQuery CDN or you load React from some other site, by default you will get no information at all because of security reasons. So we have to deal with that in a special way to add a cross-origin attribute to the script tag. So that looks like this, cross-origin anonymous on the right. And once you do that, and you set up the necessary headers on your server, access, control, allow, origin, star, then this information will be shared from this foreign resource. It's a super simple trick to get a bunch of more debugging context. So if you can't read it, yeah, feel free to come closer. So, as developers, we have a certain way of working. So if somebody comes and tells us there's a bug, there's not really much we can do. We need some context. There's a pattern of how we fix bugs. So first of all, the bug has to occur. So somebody has to find it, somebody has to report it to you, it has to be investigated by one of us, developers, and then you have to be able to reproduce it. Ideally, before you fix it, how do you reproduce it if you don't? I mean, how do you fix it if you can't reproduce it, right? And the last is the fix. So that's a kind of a flow of how we fix bugs. I hope this resonates with most of you. And like I said, if our boss knocks on the door and says, yeah, something is wrong, we need context, right? We can't just say, we can't fix it if somebody says it doesn't work, which happens to us a lot. And we need more information. So I think this cartoon is kind of very fitting. So we need a stack trace. How do you fix a bug if you don't have a stack trace? So you see how angry this guy gets. So GTFO means get the fuck out. So his boss cannot come with an error report unless there's a debugging context, which is the stack trace. Sorry for the swearing. So we need to get some context. We need to get into that debugging mode to be able to fix things. So our wish list looks something like this. We need to know the error message. We want to know what file, what line. We want to know the call stack, right? Screenshot would be great. How many have requested a customer to send a screenshot to get more information, right? So we want that. Step by step. Some logs, console logs would be nice to see. Having the user, maybe this is a QA guy in your team, a tester, then you can go to his machine and see what he's doing. That also gets you into context, right? If you're able to reproduce it live in the production environment, that's pretty awesome. That means you've reached some milestone. But the dream case is to reproduce it on your local host, right? Your own machine, where you have your own awesome tools, unminified sources, and you're not risking of breaking something in production, right? So you can fiddle around. So this is kind of what I see as the wish list for a developer. And once you have that, it's kind of this feeling that you're skiing as an ostrich. It's just, life feels good. It's just, you know you're going to fix it because you can reproduce it locally. Life is good, you're skiing as an ostrich, which makes total sense for this presentation. But this is not the only ostrich in this presentation, there's more. But anyway, as soon as you reproduce it on your local machine, life's good. That means that you understood what the user saw, you can reproduce it, you can fix it. So I like to say that a live breakpoint is worth more than 1,000 call stacks. Because yeah, that's still text, has to be parsed, thought about, reasoned, guessing. So how do people deal with error handling? Well, the most common approach, they don't do anything. So I've been guilty of this in many projects. So you just pretend there's no errors. You're a perfect programmer. I would never write a bug. Who would write a bug? We write features, right? So there's a few advantages to this approach. It's extremely cheap. It takes no time, doesn't cost anything, you don't have to buy any tool to do nothing. So it's kind of an amazing approach. But of course, bugs live forever. They form families, they have relationships, they multiply, they get kids, they form like little bug meetup groups and they meet in bars and talk about life as a bug. So that's the downside. The other one is email ping pong. So that means customer emails you, your site's broken, and you email back, okay, can you tell me some input? Yeah, I clicked this button. Okay, what did you do before? Can you send a screenshot? No. How do you send a screenshot? I can fax you. Okay, can you fax this number? So that's ping pong of emails. So I actually used somebody in here as a reference for this. No names, but we can call him Frederick. Yep. So typically, yeah, you will have a user report somebody to their internal support group, who then will contact you with some mystical debug information in a completely unreadable format, and then they will send an email to you because the user doesn't know who you are because they're far away, maybe in another country. And you just have to go back and forth and back and forth and back and forth. And now we're talking days and weeks. We're not talking like minutes to get a bug fixed. So who have done this? Email ping pong. Right. I have. Pros, I thought really long and hard about this, but I couldn't find a single advantage to this approach. Cons, it's very slow, expensive, demoralizing, customer will be angry, you will be angry, poor use of our time. Third option is to roll your own error logger. So set up an error logger method and log the results to a PHP server, MySQL database. Shouldn't take more than half a day to set up. Pros, of course, it's very simple. Shouldn't take very long. Simple database with the name field, message, stack, date. Gets you awareness, which is great. So you find out exactly what's affecting the user. Downside, of course, each time you get an error, you have to scan through the code and try to realize from call stack, what does that actually mean in my application, right? So, yeah, but still you get something. How many of us rolled your own error logger? Yeah. And then the last option is to use a third party, like Sentry, Raygun, Rollbar, Bugsnag, Stack Hunter, Session Stack. There's probably 30 of these tools that's basically error logging as a service. And you get a lot of data, so that's great. You get call stack, you get console log messages, user activity, what did they do, errors are grouped, you get statistics, so they give you a lot of intel. Downside is it's still data you have to parse, you have to read to figure out what actually went wrong. So that's kind of a summary of how we can deal with error. So there's everything from the ostrich living happily in ignorance, head in the sand, which is great, or you can use these fancy services. So we've already done these stuff. So how many of you use a third-party service? Sentry? Yeah, cool. So we thought more things can be done. So we added we created a new tool a while back called root cause. So with root cause, this looks a lot like the other similar tools. We get a nice dashboard with statistics, occurrence graphs showing you which errors are affecting which users the most, etc. And we do some things different that you won't find in any other tools. So of course you get the normal call stack, the browser info, was it Chrome, was it Android, was it Safari, etc. All these things, the stack trace, viewing source maps, all those things. I won't go into too many details here. But one of the cool things we do is we take a screenshot at the point of the error, so we can actually see the last thing that happened when it crashed. So you actually get to see what the user saw. So like basically, if you're at the murder scene, you get a photo of the killing, so to speak. So that also gives you something to start debugging with, right? You know where to start looking. And okay, this is going to be challenging. Oh, should we do Shibboleth first? Yeah. When we take screenshots, we can hide sensitive information very easily as well. So you can blur out credit card information and sensitive data. We give you an API to hide that. So this is what the screenshot will look like. And then we get tons of other things. Window size, touch support, browser plugins, cookies. If there was any failed Ajax requests. Yeah, tons of information. Got a nice little timeline of everything the user did. And the emails. So developers are always up to date. We integrate with Slack. And we can show pop-ups to the user. So what does it mean? means we don't have to communicate between QA and developer and end user and developer, because all that information just flows. So there's a full debug packet sent to developers, and they can fix the bug, and then you can notify the user via email or whenever the bug is fixed in production. So really no need to do this back and forward to request screenshots, step-by-step, talk. All that is automated. So two-way communication. Which is nice. We like automation because we're developers. And we can also have the user opt in to say, I want to give you this debug data before you take it from their client-side environment. So that's kind of a high-level photo. And then there's some stuff we cannot automate, like CSS bugs, user experience issues. If you see this button right here, the text is not really aligned and it's overflowing. You can see that, right? So there's no way to detect this automatically, but of course we can have a feedback button that lets the user tell you this is not good. So that's one part of our tool as well, to allow user to tell you about soft bugs, visual bugs, user experience bugs, the wrong translation somewhere, maybe there's a misalignment of visual elements. So that's another category of bugs, visual soft bugs. And installing this in your web app, super simple, just a few lines of code, giving us your application ID and then telling us what you need enabled in your app. What kind of features do you want? Do you want screenshot? Do you want live recording? Do you want video? So we do all those things. So that's kind of it. And I would like to give you a quick demo. So if you go to apptherootcause.io, that's where you can check it out. And we have a sandbox for pretty much all the popular frameworks: Angular, React, Vue, XJS. Who uses Angular or React? Vue, EXT.js. Only me, okay. Oops. Yeah. So if we take like an Angular demo, for example, so I added a bug here. If you click this button, the page is going to crash. So if I click around a little bit, click some checkboxes, click here, like Blyntse, because I like that, so that's good. Hello. And then some phone number. And then I click this button. Now as a user, he wouldn't normally know anything. But yeah, so we show a little pop-up here to notify the user that something went wrong on this page. And you can customize that and show anything you want. So then as a developer, you get an email or annoying Slack message saying there's a crash on the production. And this is our dashboard. So you see there's a bunch of information. Fun thing here, I can click this screenshot and show exactly the last thing that happened. We see there was a click in the DOM, and see exactly what the page looked like when the crash happened. So we get that that's already great information as a developer. You can start guessing right away what's wrong. I can watch a video of what happened. So we have a video recorded, a video stream. You can see exactly what I did. You see Blyntse type there. And I click the raise button. So again, you don't have to contact the user to ask what they did, because you have a video of the entire session, right? Magically recorded in our dashboard. And if you want to take it even further, you can do a live replay, which means basically simulate all the steps they made live in the browser. So basically one click, and instead of sitting looking at the source code, you can drink some beer. So this is debugging.next, beer-driven development. So I'm far away from the keyboard, but the bug was reproduced. So how about that? So this red is not a screenshot, this is not fake. This is the Chrome. The bug was reproduced. So you can set a breakpoint here, and you have the bug live in your developing environment, and you can run it on localhost. You can switch environment here. We have an environment picker, so maybe you don't want to run this bug reproduction in production, right? Because that could, if you're a bank, that could be a transfer money. Yeah, you don't know what's going to happen. So you run this on your staging or on your local host. So using this picker, you can define environments. So with one click and a few gulps of beer, I was able to reproduce this bug. So that's pretty cool, right? And we have lots of these demos. Backbone, for example. Click here. So you can fiddle around and just go to dashboard and replay. You can see to do, click, play again. So you see here, this is live. The bug is caught in my developing environment. So I can, of course, as in any bug, I can jump around here and check the state. So compare this to just reading the call stack, right? So using traditional error handling, what you would have, okay, now it's going to freeze for a bit. Yeah, Chrome console, it's slow. But compare that to just having the textual representation. That's a bit different, right? So having all that state, entire application state available for your debugging session, that's kind of what we try to give you. So we got the screenshot, we got the video replay for you to watch it, and we got the live replay where you can inject all the things that the user did, all the keyboard typing, the mouse clicks, window resizing, network connectivity issues, Ajax requests. We will record everything. So even database access we record, so you can inject the same response that came from the server. Just to give you the exact thing. Yes?
But what's the impact of all this, your debugging tool on the performance of application on the user side?
Very little.
This video part.
Very little. Maybe 5%. So if we go to a page here, let's go to Sandbox. Big one. So there's no way I can notice that there's something running in the background. It doesn't add any overhead. So it's streamed over WebSocket incrementally. Very, very, very little traffic. The library itself, 100K. So for a typical big application, this won't really matter. And of course, you can turn it on and off. So you don't have to add it, but if you notice some crazy bug, you can enable it for some user. So that's up to you how you add it. So very little overhead.
You can turn it on after the page renders, right?
Yeah.
After.
Right. But we would recommend that you do this early. So the earlier you do it, the more likely is that you get a good replay. So here you can see I want video. I want to record all the actions so I can have the live replay. I want a screenshot. And then I can capture user about the user information. All these things. So there's a whole list of things that you can turn on and off. Ajax recording, feedback button. So I'll just show you that one as well. That's kind of a popular one. So here's some obvious CSS mistakes. So these two completely misaligned. So your designer was out partying and then he committed this to production. Right? Not very good. So as a user, I would be angry and I want to highlight this. And I would say, okay, text misaligned. And instead of taking a screenshot and then faxing it to you or just doing something bad, they can just use your application from within the application and give you all the feedback you want.
Can you send feedback over fax?
We're working on that heavily.
Top priority.
Top priority. But as a developer, you will receive an email and you will see the message. They will say text misaligned. You can replay it so that you get to the exact state that they saw. And of course, most importantly, in this case, this is really all you need when you're talking about user feedback. They've highlighted what they saw and give a text to you what's wrong. So kind of case closed. You don't have to ask any more questions. So that's the soft box, the feedback button. And of course, if you want to get into the details, there's a timeline with all the details of what happened. You can filter for Ajax events, console logs, user activity, if there was some connectivity, if the user lost Wi-Fi, it will log that. That typically ends up you having code execute that maybe is not well tested, because that's kind of edge case, but it's nice to know, so that it might be not your most common case. So that's a high-level walkthrough of root cause, and then you can add tags to the code. We have a tag section here. You see which environment, Mac, Chrome, 4062, information about the user, their email. So you can basically have everything you need to fix the user's mistakes, or your mistakes found by the user. So did I miss any obvious features? Yeah. So we've been using this for about a year, and we have moved from trying to find bugs ourselves manually by clicking around to basically now receiving a bug report in the shape of a test case, which we can click, play on and on again, as many times as we want to fix the issue. You can play it on localhost, you can play it in production, so you can fix the bug and then replay in localhost to see that the bug is gone now. So we have all these advantages now, and bug fix can be done in maybe half hour and then pushed to production. So no more these like long days of emails with customers, and they send you screenshots in the email, and you have to look at the screenshot and like, oh, what did they do? How could they reach this state? But instead we give you a sequence to play back, so you can reach that state and see what they're doing. So, trying to sum up.
You've got their Jira integration.
Yeah. We also have integration with this is not here. But we can export this to JSON, we can export to Jira, and we have integration with Slack. And we're working with more integrations based on customer feedback. So if you have Jira, you can just export this and have all the context in your normal ticketing app. And of course you can assign it to users. And you'll see this showed up here. I assign myself to this bug, and that will be broadcasted via Slack, so that your team is up to date with what's going on. So that's pretty much it. Technical details. Recorder built with 100% JavaScript, vanilla, no secrets, nothing funky. Screenshots are done with HTML to Canvas. We record video via the DOM mutation API by a Google library, open source. Dashboard is made with XJS because we use that a lot. And the replay studio is powered by our testing tool, Siesta. That's what actually simulates all the events and ingests the DOM. So what this means, if we go back to this slide, where we have this chain of stuff that has to happen for us to fix a bug, we've now skipped basically the report and investigation part. That's automated. So we can jump straight into context where we have the bug reproduced and just have the fun part of bug fixing, not the boring, like where you want to jump off a cliff part, right? So I see this as a huge time saver. And of course, support for every library, because this is just basic JavaScript, Angular, React, Vue, doesn't matter. Any page, any website. And that's it. So make sure your external script tags are fixed with this cross-origin attribute, so you don't have to see script error ever, because there's no reason it should be there. Don't rely on users reporting bugs. We can do better. It's easy to have this automated, to have this information flow into your inbox or your apps. And automate your error reporting. And if you want to give this a go, at therootcause.io. And sign up. There's a free version, of course, with a nice video recording and everything. And to sum up, I see it now as no longer breakpoint or GTFO, but live breakpoint or GTFO. So that's the way we see it. Any questions?
So is there some filter in the private dashboard side? So for instance, if a certain error event happens now 10,000 times, you get 10,000 edges.
No, so good question. We group by application, stack trace, and not message. So it's stack and file. Yeah.
The function is.
Yeah. So the message could be in different locales. So if you have a Dutch version and a Chinese version, it's still the same error, but the stack trace will look the same. And we'll have an option for you to group errors yourself as well. So.
Ability with browsers, especially mobile tablets, iOS.
Well, the nice thing about mobile, they're quite advanced. So I was happy you didn't mention IE. But I think it's IE 10 and upwards, and mobile browsers, that's all Safari. So they're good. So anything that's web. But IE 8 and that stuff, IE 9, yeah, will just give you a normal error message, but you won't have the fancy video and replay, because those APIs don't exist. Anybody else?
I mean, clearly it's a big advantage for the developers, every tool, but how about customers? Do you really want pop-ups and everything? You want to interfere with RTI?
So everything is off by default. So let me just show you. So if you add the feedback button, you get this, right? It's off by default. It's on in this demo. Show feedback button. But yeah, it doesn't have to be there. If you want the confirmation dialog, you can have that as well. But this is also a flag you have to enable. You can do it completely without the user knowing. But then depending on the laws in your country, or yeah, some countries don't allow you to take all that user privacy information. It depends on, but we give you all this information, all the configuration options, so that you can decide yourself. And to also show you how we take screenshots. So if you have some information like this, social security, password, credit card fields, if I simulate a screenshot, you see how we take it out of the DOM and obfuscate it. And if I would make a crash here, you see that it flashes temporarily. And then I can go to dashboard. And this is a screenshot. I can see that I click the crash button, but I don't see these secret fields, right? And that's something that we give you out of the box. So you just tell us which fields to ignore. Blackout selector. This is just CSS, so type password, right? And any CSS, credit card input. So we try to give you as much control as possible. But if you don't enable anything, then the user will have no idea that an error happened at all, or that it was logged. So they will just return an hour later, and then you'll fix it already, hopefully.
It's free product or is it price?
Both. Done. So there's a free version which has a bunch of stuff: error reporting, video recording. This is the free option. Hobbyist, you get 2 applications, 50 errors per month, 50 unique errors. So not like 50 times there was some crazy error. If it's the same one, we count it as one. So we try to be reasonable. If you want a live replay and the feedback button, that's a startup plan. And then there's a business plan and enterprise plan for bigger teams with the integration requirements. If you want Jira, if you want the Slack integration, that's part of the bigger package. You can also run this standalone behind a firewall. So we give you a Docker image and you can install it in your server, and the error information doesn't go to us. But by default, it's a software as a service, right? So the errors are in the cloud. Yeah. So, but yeah, easily to get started. This is free. There's free trial of all the bigger plans if you want to try all the features.
Include the feature about pulling in plugins which the client had installed.
Yes. So you see here, install plugins. That's by default.
Can I get the light version of this? Maybe to speed up.
Yeah. I mean, if you just want a screenshot, you can take out the video recording part and the live replay part. So you'll have a very small footprint, definitely maybe 50K or something at max. And it will be cached, so I wouldn't worry too much about the performance. And it only takes a screenshot when there's an error, obviously. So it's not some overhead or things like that. So, and yeah, like I said, we've been using this for quite a while now. And so these are our bug reports. This is not mock data demos. This is real errors that people are finding on our site. You can see that there was a pointer down. Maybe this is an edge case. They clicked the last pixel. Maybe we have some edge case there that we haven't tested. But the cool thing here, I'm a kind of a cheap bastard. So what we get here is free testing. Our users become our test monkeys without knowing it, which is kind of brilliant. So we don't have a fancy QA department because we're kind of a small startup, but anyone going to our website, by default, they give us test cases. And we can repeat those, and we can improve the products so that next time somebody comes, it will get better and better and better. So, of course, it's very, very late to detect an error after release, but it's much better to detect it than having the user see it and walk away, right? So, well, okay, one last one.
Is there any way to record backend errors?
Well, we have some flags for that. Let me see. Where is this? Actually, let me. I'll show you how we use it. So it's not a server logging tool, but we do offer flags to treat failed Ajax as an error. So if there's a 404 or 500 server error,
I didn't mean that. I meant like if you have a backend and client side logging, then you need like two applications to handle all the logging.
yeah, if you want a separate site to log your PHP or Ruby or Java, that's a separate. We don't handle that.
Do you have like an API where you can have some other service like pull the information so that you can have one stream of errors?
Not at the moment, but we could easily add it. Because we have a nice API that can be queried that we use for the web UI. There's no reason that cannot be extended to feed it to some other UI. That would be totally doable. Good question. So yes, I just want to say thank you very much for listening to me instead of enjoying the nice weather. So thank you very much again.
So it's nice weather, yes.
It is, yeah, it's amazing. We don't have that in the north. But yeah, thank you very much. Should we do a lightning talk with it?
Yeah, you want to do that? Straight up? Sure. What's the name of the song? So if anyone wants to do a lightning talk today, anyone? Oh, there's one! Awesome use cases for UAT and Boston. Have you got any other lectures around maybe I could. So this is going to take 5 to 10 minutes.
Quick break.
Quick break. Can I use your computer? I haven't got the correct one.
Yeah.
Anyone in the audience may have a
I have it as easy to HMI, but it's not. This is VGA.
Okay, so maybe someone here might have one.
So again?
You want live on custom?
Okay.
Yeah. Yeah.
young gentleman right here. Ah, this one.
So
He had the courage to step up and do a lightning talk on performance profiling in Chrome. So I'm looking forward to hearing that. Are we going to be talking about Lighthouse?
no.
Oh, awesome.
And it won't take too long. So my name is Johan. I'm with the Bryntse team, and it's actually my birthday today.
Happy birthday!
So as a gift from the team, I get to do a performance profiling short session.
Best gift ever.
Best gift ever. Great fun. And me and the team, we are here for a week, doing like internal conference, working on stuff, bashing tickets and fixing bugs. And we are also having some internal sessions. And I did a session on performance profiling the other day, and my colleagues liked it. So I'm just gonna share some quick things. And this applies mostly to Chrome, how we profile it. But the things you should think about, I guess, applies in all browsers. So I'm just gonna show stuff instead. I have opened some different data grids, or what you called grids earlier, but now when you say grid, you mean more of like the layout of the page and stuff, but data tables or data grids. And we supply JavaScript components, so we make our own grid, but this isn't it. This is the XJS grid, which we are using in some of our products. And I'm just gonna start by showing you a profile of it.
So many, here we go.
So I'm gonna open Developer Tools and go to the Performance tab. Then I'm gonna record. And for a grid, it's kind of critical that it scrolls nicely and that it loads decently fast. But scrolling, if it's laggy, it's a bad user experience. So I'm gonna try this one. I'm gonna record, and then I'm gonna scroll. Just a little. That should be enough. And then I'm gonna stop. So now I'm getting a flame chart, I think it's called, displaying all the JavaScript calls that happen during that little scroll. And if we start from the top here and zoom in, you can see that we had we can't really see it, but almost. We had a scroll event from me dragging the fingers on the touchpad, and that triggered some function, which triggered some function, which triggered some functions. Pretty many functions being triggered. Let's zoom out. Some of these ones go really deep. You see, each row is a function call happening after each other. We also see how long time it took. So up here we can see that this scroll event took 47 milliseconds. And for scroll, we want to keep it at 60 frames per second, which gives us 16 milliseconds to both execute our code and have the browser draw everything. And in this case, we kind of missed that mark. This frame took almost 70 milliseconds to do, which gives us 14 frames per second. And that's not super good. Let's check some other grid. Doing the grid checking. And also, when we are at it, you can see here that mixed among the JavaScript calls, there's also some pink boxes. That's the browser doing stuff, the purple boxes. So in here, in the middle of our code, the browser had to recalculate the styles, and it also had to redo the layout of things in the browser. So we want to avoid that. We want to do our stuff, and then the browser should do its stuff. But in here, the browser is doing stuff in the middle of our code, which will delay it. So let's check another grid. This is a React component from Facebook. Okay, so I'm just gonna do the same thing. Scroll and record what's happening. And here we will see the depth of this call stack. Yeah, so it's like, I don't know, 1,000 functions being called after each other for the scroll.
Show the FPS value.
1.
So also Chrome is kind of angry here that things are taking a long time. So here we are getting, let me zoom in. Like 9 frames per second, 16, 10. Not super fast, but it uses request animation frame to throttle the scroll. Okay, so set animation frame runs at 60 frames per second if everything is as it should, and it allows you to like safeguard against having relayouts and stuff in the middle of your code. So if you do that, the browser mostly will do its stuff after you're done. But you still need to do your stuff a lot quicker than this to have 60 frames per second. Let's try somewhere else. So this is agnostic grid something, and they have very many columns. Let's close some of them to have it more like the others, not like that. And see what happens when I forgot to add the rows. Give us 100,000 rows maybe. Okay, and the columns returned. Sorry about that. Let's close them again. Okay. Let's see what we get. Yeah. So here it's more or less the same. A lot of calls going on. More or less the same. Slow. And I have one more here, but we don't need to profile this one. This is the million row example, and if I scroll, yeah, we don't need a profiler for that. That's not good. Okay, so this is our grid, and I'm not going to talk too much about it. I'm just going to show you what you can achieve. So I record the scroll here, and we can see that we are doing things. Our code runs in 1.5 milliseconds instead of like 60 milliseconds or 100 milliseconds, still doing mostly the same things. So it is very possible to write decently performing JavaScript code. And in our code, it's the browser doing most of the work actually. And this view also gives you a nice overview of what's happening in your code. So we'll see, you could see timers triggering and stuff intervening that you thought wasn't happening maybe. And you can also, if you display you select a certain part here, you can get summaries for which functions is taking the total amount of time, where should you focus your efforts for optimizing. And you can also, if we are lucky, jump into a function taking a lot of time, and you can get numbers. It's hard to see here. Let me collapse that. Yes, I'm trying. So I have borrowed Matt's computer, and he had remapped the keys. So
in a nice way.
So we get measurements in code for which lines are taking the longest time. So it's a super nice, helpful tool to use if you're into performance stuff. And I prepared a simple, small demo just to show something that is easy to achieve. I think it is not near. If I spelled it correctly. Okay. Yeah. So this demo, which we are going to try to fix, it just generates data. It generates, I don't know, maybe 80,000 rows of project data to be viewed in a Gantt chart or something. So there's projects with sub-rows and stuff. We don't really need to see it. It just, we can see on the console, it took 3 seconds. Sorry, zoom in. It took 3 seconds to generate the data in this demo. And that's way too long for 80,000 records, or whatever you call them. So we should try and take a look at what was taking time. And there I have already mentioned that we want to avoid having the browser running stuff in our code. And among those things, we will see the one of them here soon. So, I want to make a profile from when I load the page. So I hit the reload button here in the performance tab. It reloads the page and starts the profiler immediately. And we can see here, this is my generate data function call. It takes close to 3 seconds. And if we zoom in, you can see here that the browser is doing a lot of garbage collecting in our code. So we are doing something which we shouldn't, which uses memory and triggers the browser to garbage collect. We could also profile memory and stuff, but that's not much. So a quick look at the code. I have it here somewhere. Yeah, so it's basically a pretty big function. Yeah, so it's basically just a big function that generates a JSON data in a tree structure hierarchy thingy, and it does this a certain amount of time. So I'm repeating a data structure. And the thing that triggers the garbage collecting here, it might not be immediately obvious, but we are concatenating arrays, which yields a new array. So now I already know this, and I have prepared a fix. So instead of concatenating arrays, I can push apply. Here's remap the keys. I don't know how to copy and paste. Yeah, I got it. Okay, so I just changed from concat, which is a new array, to push apply, which does in place the stuff instead. And now we're gonna try it. So the last try was 3 seconds. Oh gosh, it's cached here. Okay. Let's do a hard reload and try again. It's still, he hasn't put, I pressed the wrong key to save.
There you go. Sorry.
My bad about that. Trying again. Yeah, so we went from 3 seconds to generate data to 140 milliseconds. So big gain. So bottom line, performance profiling in Chrome, that's a great tool. You should use it if you have something performance critical. And that's it for me. Thank you guys. Yay.
Questions?
Oh yes, I forgot that part. Any questions? No, crystal clear.
No questions. No,
Good. No, probably not.
Good.